All right, well, welcome back, algebra students. This is Mr. Von Ah. So glad you could come back. We are in our third lecture, Unit 4, Lesson 3. And today you will be, you're going to learn how to find the greatest common factor, or the GCF, of a polynomial. Sound exciting? All right, I'm glad you're excited because I'm excited. All right, so first off, we need to ask the question, what is a factor? Right? That's the key word right there, factor. Okay, so just to kind of illustrate this, I want you to consider the number 15. All right, so if I were to ask you to factor 15, how would you do it? Well, I don't know if you remember doing this way back when. Remember those factor trees you used to make? Well, what are the two products, or what are the two numbers that give you a product of 15? Well, actually there's two different alternatives. All right, so I'm going to do both of them. All right, we could do 1 times 15. Okay? And if this was a prime number, that would be the only option. But 15 is not a prime number. We can factor it another way. We can factor it as 3 times 5. Okay? So factoring, really, it's just expressing a number, or in this case, a polynomial, as a product. Right? If I want to factor 15, 3 times 5. I just factored it. All right? So let's kind of go one more step, and let's see if we can find the greatest common factor. All right? So to do this, we need at least two numbers. All right? So let's take the numbers 20 and 30. All right? So first of all, let's take a look at the number 20. What are the factors of 20? Well, we know that 1 times 20 is 20. So I'm going to put a 1 here and a 20 over here. Because I'm going to list them out. All right, I know that 1 times 20 is 20. What else equals 20 when I multiply? Well, you guessed it. 2 times 10. So 2 and 10 are also factors of 20. Okay, and I have two more factors. Do you know what they are? How about 4 and 5, right? 4 times 5 is 20, 2 times 10 is 20, 1 times 20 is 20. These are all of the factors of 20. All right, now how about 30? What are the factors of 30? Well, the easy one, we know 1 and 30 are factors of 30. Can you think of any other factors? Well, that's an even number. So I know that 2 will divide into 30 evenly. So we want 2 times 15. There are some more factors. How about 3? 3 times 10 is 30. Oh, I'm running out of space here. How about 4? 4, will 4 go into 30 evenly? No, 4 times 7 is 28, right? How about 5? Yeah, 5 times 6. So 5 and 6 are both factors of 30. So these are all of my factors for 30. Now, here's the question. What is my greatest common factor? Well, first, let's back up. What are my common factors? Well, I see that 1 is a common factor, and by the way, 1 will always be a common factor, and it really doesn't help us in this case. 2 is also a common factor. 4, no. 5, yes. 5 is a common factor. 6, no. 10, yes. 10 is a common factor, and it just happens to be the greatest common factor. All right, so in algebra, we're not so much interested in common factors, but we're interested in greatest common factors. All right, so all it means is what is the greatest number that is a factor that both of these numbers share as a factor? They both have 10 as a factor. So 10 would be the greatest common factor of 20 and 30. All right, so let's take it another step up. We're going to hit into some algebra here. How about let's find the greatest common factor. Find the greatest common factor of, let's get some examples here. Let's try x squared and x. X squared and x. Okay. Well, to do this, let's go ahead and factor each one of these terms. Okay, so let's factor x squared. What times what is x squared? Well, x times x is x squared. All right, how about x? How do I factor x? Well, remember, you can always factor anything with 1. So it would be what? 1 times x? So here's my question. What is the greatest common factor between x squared and x? What's the largest thing they have in common? Well, they both share an x in common, don't they? See that? So you got it. Your greatest common factor would be x. Is my GCF. Is x. Okay, and you can see it right here. They both have an x. This has one x and he has two x's. All right, so they share an x in common. All right, let's try another one. What if I had y to the 6th and y to the 4th? What is the greatest common factor? Well, let's see here. An easy way to think about this is well, this has 6 y's and this has 4 y's. Right? So this guy does have 4 y's plus 2 more, right? And he also has 4 y's. So if I was to factor y to the 6th, I could factor him as y to the 4th times y to the 2nd. See that? The 4 plus the 2 is the 6. And I could factor y to the 4th as y to the 4th times 1. Do you see the greatest common factor? You got it. Y to the 4th would be your greatest common factor. So the greatest common factor would be y to the 4th. All right, let's try one more. Let's try one more, and I'm going to need some space here. Let's find the greatest common factor of 12x to the 3rd and 16x squared. Oh, all right, now we're getting a little more complicated, right? Because now we have numbers and we have variables all at the same time. But here's the deal. How do you eat an elephant? Well, just one bite at a time. All right, so that's how we're going to do this. We're going to do it, take it one step at a time. First, let's just look at the numbers. Okay, I have 12 and I have 16. All right, what is my greatest common factor between those two numbers? Well, maybe you know it. Let's try it over here. If I have 12, and I have 16, what are my factors of 12? Well, 1 and 12, 2 times 6, and 3 times 4. All right, those are all my factors of 12. Factors of 16, 1 times 16, 2 times 8, 3 and 4 times 4, is that right? Okay, so what's the greatest common factor? Let's see, 2? No. 4? Yes. 4 is my greatest common factor. It's the largest number that is divisible by both of these numbers, even. All right, so 4, I'm going to take a 4 out of here. All right, pull a 4 out of there. Okay, now I move to my variables. I have an x to the third and I have an x to the second power. What's the greatest common factor? Well, this has 2 x's and this has 3 x's. But couldn't I factor this guy as just x squared times x to the first? So that x squared would be my greatest common factor? Right, if you want me to show that. Kind of like what we did down here. X to the third, and I have x to the second. I can just factor this as x squared times x to the first, right? And I can factor this as x squared times 1, so that my greatest common factor is x squared. And lo and behold, this is my GCF of these two terms. All right? Not too complicated. You can do this stuff with a little bit of practice and a little bit of help from me. All right, so let's go ahead and switch over to finding greatest common factors when we're given a polynomial. All right? This is where they fast forward the YouTube video, right? Okay. So let's say I want to factor 4y squared minus 8. Okay? That's a binomial, isn't it? It's a two-term polynomial. Okay? I want to factor this. What I'm going to have to start with is I'm going to have to find the greatest common factor. Okay, so I look at both of these terms. I look at 4y squared and I look at the 8. And I think to myself, 4 and 8. What is my greatest common factor between those two numbers? Well, I could do this, right? 4 and 8. 4 is 1 times 4 and 2 times 2. Right? 1, 2, and 4 are the factors of 4. 8, I can go 1 times 8 or 2 times 4. So that my greatest common factor, ladies and gentlemen, is 4. All right? So what I'm going to do with that 4 is I'm going to set him over to the side right there. Okay? Now I need to, basically what I'm going to do is I'm going to use the distributive property in reverse. Pretty much that's what factoring is. Factoring is the inverse of distributing. And all distribution is multiplication, right? So factoring is really just dividing. Okay, so if you look, what's 4y squared divided by 4? Well, 4 divided by 4 is 1, right? So what am I left with? Just that y squared. So I'll do that with a different color here. See that? Now if I use the distribution property, 4 times y squared is 4y squared. See that? Now I have this subtraction symbol there. I'm going to go ahead and put him in there. Now, again, divide. 8 divided by 4 is 2. 4 times negative 2 is negative 8. So I just factored this binomial. Remember, factoring is just expressing a polynomial as a product, right? Is this a product? Yeah, this is 4 times the quantity y squared minus 2, okay? So I just factored that. Let's try one that's a little more difficult. All right, here we go. Let's try 3x to the third plus 7x squared plus 6x. Oh, it looks intimidating, doesn't it? Well, it's actually not too bad. All right, so I want to factor this. That's the instructions. Factor. I have to put that right here. Factor. Okay, so first thing I need to do is see, well, is it in descending order? There's my highest degree, my second highest degree, my third highest degree, right? So it is in descending order, which is good. Okay, now the next thing I need to look at, does it have a greatest common factor? Okay, so first I'm going to look at my numbers. 3, 7, and 6. Do I have a greatest common factor? Well, 3 and 6, the greatest common factor would be, well, let's just go ahead and try it down here. Let's do 3, 7, and 6. Okay, the factors of 3, 1 and 3. It's a prime number. Factors of 7, 1 times 7, another prime number. Prime number, that just means it has only one factor, the number itself and 1. 6, now 6, you could go 1 times 6 or 2 times 3. It's not a prime number. Okay, so we see something interesting here. We see that the 6 and the 3 both share a 3 as a factor, but the 7 does not have a 3. And so remember, all the terms have to have a factor in common, and the 7 just doesn't have a 3 in common, so therefore the whole thing is out. So I cannot factor out any number from this trinomial, okay? But now let's look at the variables. All right, so I have x to the third, x squared, and I have x. Is there a greatest common factor there? Well, let's take a look. I have x to the third, I have x squared, and I have x, right? Well, I could factor x to the third as what? X squared times x to the first, right? And I could factor out x squared as x to the first times x to the first. And x to the first, I could just factor as x to the first times 1. So what's the greatest common factor? Well, it's just the smallest degree term, in this case, x to the first power. All right? So I can pull out an x because each term has an x in common. All right, so let's go ahead and take that x over to the side. And again, now we're just going to divide or do the distribution property in reverse. All right, so what's 3x to the third divided by x? Well, I know I'm going to need a 3 there, right? So x times 3 is what, 3x? But I need to account for that 3 in my exponent. Now if I put, so I need an x, correct? So x times x is what, x squared? Oh, not quite. But if I put a 2 there, x times x squared is x to the third, right? Just like what we had right here. Okay? So again, you're just adding these exponents. And now we go to the next term. X times what is 7x squared? Well, I know I'm going to need a 7. So I got x times 7 is 7x, but I need another x in there, don't I? So x times 7x is 7x squared. Boom, just what I have there. Now I'm going to make this out a little bit further. Now I need a plus sign there. So 6, I'm going to need a 6 here because I don't have a 6 out here. So x times 6 is 6x, which is exactly what I have. So I don't need to put any x here because the x has already been provided for right here. Okay? And that is factored. We'll learn on our next video how we can factor that more completely. Okay? So I hope that this was helpful for you. Again, this just takes some practice. Make sure you go on Khan Academy and make sure, as far as my students, make sure you subscribe to this channel so that you'll get notifications every time I make a new video. All right? Well, God bless you, my friends, and have a wonderful day.